For this video, I'd like to talk about quadratic equations with complex solutions. So for all of these problems, we're basically going to apply the quadratic formula, but this part where we have the square root in the quadratic formula. In these problems, you're often going to find this to be a negative number, and we'll have to simplify it based on that fact. And remember, visually speaking, when we're using the quadratic formula, usually we have some type of parabola that's going to cross this x-axis at two different points. This is kind of the most typical case. And if this was the case, both of your solutions would be normal real numbers. There's also a case where it comes down and just touches it at one point. And so that's the strange case where you actually only have one solution, but technically we consider it a double solution. And this is the case where this discriminant here, this square root term, is essentially 0. And so you add or subtract 0, and so that's how you only get one answer. And then there's the third case, where our parabola does not even cross the x-axis. So a case like this, where it doesn't have any x-intercepts. But we can still set up the equation. I can still set up the equation and set it equal to 0 and ask, well, what are these x-intercepts? Even though the graph doesn't go through those. And so what you can expect is that if you have a parabola that doesn't actually cross the x-axis, that when you apply the quadratic formula, you're going to get complex numbers or imaginary numbers, numbers involving the square root of -1. So visually speaking, this is what's happening, and that's why when solving this, you don't get normal numbers, because it's not actually crossing this x-intercept where y is equal to 0. So with that in mind, let's match up what a, b, and c are from our standard form so that we can apply the quadratic formula. And from this quadratic they gave us, looks like a would be -3, that's the coefficient on x squared. B is the coefficient on x, which is 6, and c is the constant, which is -11. And the signs are important, so make sure you're carrying those along. Now we're just going to plug everything into this formula. So we have the opposite of b. So let me change colors here. So that would be -6 plus or minus the square root of b squared. So we have 6 times 6, which is 36. And by the way, this term here is always positive, because if you put in a negative number and you square it, a negative times a negative is a positive. So just keep that in mind. It is a useful thing to know. And then we're subtracting 4 times a, which is -3, and times c, which is -11. And we're going to divide this all by twice a, or twice -3, so that's -6. And often with these problems, the hardest part is going to be simplifying it. Plugging in all the values is not necessarily overly challenging, but simplifying the square roots can be very difficult. So let's try and simplify this as best we can. So let me go up here. We have -6 plus or minus the square root of 36. And then we have 3 negatives. So we're going to end up having 2 of them cancel, and we have 1 left. And we have 4 times 3, which is 12. And 12 times 11 is 132. Again, dividing all by -6. So from here, we simplify even further. This square root here, so we have -6 plus or minus, and 36 minus 132. And that simplifies to -96, and then all divided by -6. And at this point, we need to simplify this square root of -96. Let me make some space, and we'll work on this up here. So this is kind of the most tedious part of these problems. First of all, we can separate out the -1, because technically this is -1 times 96, which is the same as the square root of -1 times the square root of 96. And this square root of -1, remember, we just defined that as the letter I. So really, this just becomes I root 96. And now we want to simplify the square root of 96. So we'll make a tree. Let's see, 2 goes into 96, looks like 48 times. 48 is really just 6 and 8. 8 is really just 2 and 4 is really 2 and 2. 6 is really 2 and 3. So in total, let's see, looks like we have 1, 2, 3, 4, 5 2s, and we've got 1 3. And so to simplify this, I'm going to split it up into its pairs. So 2 squared times 2 squared times 2 times 3, which I actually just recombine to make 6. And so simplifying this, the I is still in front, you get your 2 squared times 2 squared times 6. And then the 2 squareds can be simplified. So when we break this up into their individual square root, we know when we take the square root of something squared that they cancel, and you just get back the number on the inside. So let me just continue this down here. And I root 96, well, we'd get a 2 and a 2 on the outside, so that's 4. And then I carries, and then we still got the root 6. So let's replace that and see if we can simplify further. So minus 6 plus or minus 4i root 6 all over minus 6. Now, this negative 6 is dividing into both of those terms. So we could separate it into 2 separate fractions and then simplify each separately. So we have this minus 6 divides into this term and into this term. So you got to be careful when you're dividing a binomial by a number. So you have minus 6 divided by minus 6, and then we have plus or minus 4i root 6 over minus 6. And by separating it into 2 fractions, now it's a little bit easier to simplify. Minus 6 over minus 6, that's just 1. And then this one becomes 4 over 6 simplifies to 2/3. So you get 2i root 6, and we'll keep the minus 3 on the bottom. Now, some of the multiple choice questions may or may not show this as an answer, so you always got to be a little bit careful. They might have this as an answer. It's always a little bit different. They might also just divide top and bottom by 2. So you might also see it so that they can keep the same denominator as minus 3 plus or minus 2i root 6 over minus 3. Notice that every constant term was just cut in half. So this is another way you might see it. And honestly, most of the difficulty with these Khan Academy exercises come from trying to find the right simplification. So just keep that in mind. Sometimes you got to kind of play around with it a bit to get the answer that you want.